Welcome! This video is on finding the best fit line when we have a scatter plot and finding the correlation coefficient of the data. In sheet 1, we have the scatter plot that shows the January unemployment in Arizona with respect to year. In sheet 2, we will make a scatter plot to show the June unemployment numbers with respect to year. If you recall, to make a scatter plot, you click on Insert at the top, go over to Scatter Plot, pick the basic scatter plot, click into the plot, and you will get Select Data. Add legend entries. For X value, put the year, which is our explanatory variable. And for Y values, select all of the data for the unemployment numbers for June. That's our response variable. I can pretty this up by adding a chart title and 2 axis titles. And we are done with the second scatter plot. For each of these scatter plots, I'm going to put in a best fit line and find the correlation coefficient. Once we have that for each scatter plot, we will compare the unemployment number data for January with the unemployment number data for June and see which one has data that is more linear. To add the best fit line, right-click on one of the data points. You'll see Add Trend Line as one of the options. You want to click on this. Over here, Linear. We are doing linear regression in this class, so Linear Trend Line. Scroll down, click on Display Equation on Chart, and Display R-squared value on chart. I like to move these up so that you can see them better. My equation is 54,229x minus 1 times 10 to the 8th. And my R-squared value is 0.8617. Remember that R-squared tells us how much the change in the response variable could be explained by the explanatory variable. R-squared is the square of our correlation coefficient. So if I want to find our correlation coefficient R, I'm going to take the square root of this. So equals SQRT, open parentheses, 0.8617, close parentheses, hit enter. So this is my correlation coefficient. When I do this, I have to pay attention to the sign. R squared is always positive. R is only positive if this seems to be an increasing line. It is, so I'm going to type that in for us. R is positive because the line is increasing. Great, so we've got our equation and our R-squared value. Taking the square root, we found R. Let's go back to the data from January and do the same thing. Right-click on one of the data points, click Add Trend Line. We want linear. Scroll to the bottom, display equation on chart, and display R-squared value on chart. Again, move these up. We see our equation is 53,557x minus 1 times 10 to the 8th. And here the R-squared value is 0.7992. Once again, the correlation coefficient R will be the square root of R-squared. So in this case equals SQRT, open parenthesis, 0.7992. And the R value is 0.89398. Again, this R value is positive because the line is increasing. Notice the correlation coefficient here is 0.89398. That's a pretty strong correlation. The correlation over here, though, is 0.9282. That's a stronger linear correlation. So the data for June would be more linear than the data for January. Now, suppose you had data and you wanted to find the correlation without making a scatter plot. You can do that using the equals CORREL function. The easiest way to do this would be to go to our function button, little f sub x. In the brief description, type correlation. Click go, and CORREL comes up, returns the correlation coefficient between two data sets. Click OK. Array 1, we can highlight the year. Array 2, we can highlight the unemployment numbers for January. Click OK, and we get 0.893981 just like we had over here. The Correl function will give you positive or negative. You won't have to double check that. The Correl function will tell you right away if it's positive or negative. That is finding the best fit line and correlation coefficient using Excel.